Network topology architectures are a fundamental topic in networking. Understanding these different designs is crucial for anyone building or managing networks, from small businesses to enterprise-level infrastructures. Today I will cover subdomain 1.2 of the CCNA exam blueprint, which describes characteristics of various network topologies. So let's start. The three-tier architecture is a classic for large enterprise networks. It's built for hierarchy, reliability, and scalability. The access layer is where the end devices connect. Think of it as the edge of your network. The distribution layer acts as an aggregation point for the access layer switches. It handles routing between VLANs, implements security policies, and provides quality of service. In other words, it's the control point. The core layer is the high-speed backbone of the network. Its primary role is to provide fast, reliable packet forwarding between distribution layer switches without any complex processing. It's all about speed and efficiency. This design is highly scalable, meaning that you can expand the network just by adding more access, distribution, and core switches when needed, but it can be complex and costly to implement. Two-tier architecture or collapsed core design is often seen in smaller to medium-sized networks. In a two-tier architecture, we essentially combine the distribution and core layers into a single tier. You have access layer where the end devices like computers, phones, and printers connect. Above that, you have combined distribution and core layer that handles routing, policy enforcement, and connects to external networks like the internet. It's simpler to manage and more cost-effective for networks that do not require the immense scalability of three-tier design. The spine-leaf architecture is prevalent in modern data centers and cloud environments. The spine layer consists of high-speed, high-density switches that act as the backbone. The leaf layer consists of access switches that connect to servers and other end devices. Every leaf switch connects to every spine switch. This design creates a flat, non-blocking network that's incredibly efficient for horizontal traffic flow, which is critical for virtualized environments and distributed applications. It also simplifies scaling, as you can add more spines or leaves as needed. Every leaf switch connects to every spine, so you have a predictable path of 2 hops from any server to any other, for example from a database to application server. Wide area networks, or WANs, connect geographically dispersed locations. Unlike LANs, which are typically confined to a single building or campus, WANs use technologies like MPLS, dedicated leased lines, or the internet to link offices, data centers, and remote users across cities, countries, or even continents. The primary characteristics of a WAN are its scale and its reliance on telecommunication service providers to provide connectivity over long distances. It's how businesses connect their branches or how you access resources hosted far away. A small office, home office, or SOHO is what most of us are familiar with. It's a relatively simple setup, typically centered around a single all-in-one device acting as a router, switch, firewall, and wireless access point. It connects a small number of devices, computers, printers, smart devices, to the internet. Simplicity, ease of management, and cost-effectiveness are key with this setup, rather than high-end performance or complex security features. On-premise and cloud. This distinction refers to where your network infrastructure and services are hosted. On-premise means your organization owns, operates, and maintains the physical hardware and software on your own premises. You have full control but also full responsibility for everything, including power, cooling, security, and maintenance. Cloud refers to services and infrastructure delivered over the internet by a third-party provider. Instead of owning servers, you rent computing resources like virtual machines, storage, and networking from providers like AWS, Azure, or Google Cloud. This offers scalability, flexibility, and often reduced operational overhead as the provider handles the underlying infrastructure. And that wraps up our look at network topology architectures for CCNA exam topic 1.2. See you in the next one.